Okay, now let's see the second methods of integration, which is integration by parts. Well, integration by parts is actually the opposite to product rule in differentiations. So in differentiations we have product rule, but now in integration we have integration by parts. Integration by parts is used when you cannot use integration by substitution to solve or integrate the function, and usually inside the integrand we have two functions. Of integration by parts is integrations of u dv equals to uv minus integration of v du. Okay, so this formula you have to remember. Now, what is u, what is v, and what is dv? Well, as I mentioned before, the integration by parts is actually coming from product rule. Let's say before this we have for product rule we have two functions, fx and gx, and using the product rule where we differentiate this one, we have to differentiate f first and remain gx, and we remain fx and we differentiate gx. Okay, that is product rule. And if we want to integrate, we just put integration for all the functions. Okay, integration and differentiations, the symbols gone, and we just left with this function. Now let's rearrange it. So let's bring this one to here. So this one is fx g prime x equals to fx gx minus integration of f prime x gx, and if we have integration we put dx at the back. Okay, let's compare with these u dv equations. So u, let's say we substitute fx as u, gx as, okay, u is fx and v is gx. So mu prime is f prime x and v prime is g prime x. Okay, let's compare now. So u dv, this one is u g prime x is dv v prime. So we have u dv equals to fx. Fx is uv. uv minus integration of f prime. F prime is u prime, which is du. G is v. That's how these equations coming from. It's actually coming from the product rule. Okay. Now, how to determine which one is u, which one is dv? When you have two functions, let's say you have to solve integration of, okay, let's say, what if you have x sine x dx? When you try to substitute using the substitution method, you cannot use it because one function is not differentiations of the other function, so you cannot use substitution method. So let's try to solve using integration by parts. Integration by parts, you have to transform this equation and become in terms of u dv. And how to determine which one is u and which one is v, du and which one is dv? So for that, you have to use this one, LIATE, liat. I think some of you already know this one, where L is ln, I is inverse Pigou, A is algebra, T is trigo, and E is for exponential function. So when you have two functions, which one is u, which one is dv, it depends on this arrangement. Okay, let's say x sine x. What category is x and what category is sine x? So x is algebra. So this one is algebra. And sine x is trigo. So you have to make sure you choose which one is u and dv, not uv. You have to choose u dv. So the equation inside this one is u dv. So this one algebra coming first means that your u is x and sin x dx is dv. So now you have u dv equations. Okay, now when you have u, you have dv, put it left side and right side. Your u is x, dv is sin x. Okay, now for left side, you have to differentiate. Right side, you have to integrate. You can make the table as well. It's okay. So, if you have u, left side, you have to differentiate. Means that you have to get du over dx. So, when you differentiate x, it become 1. So, I just move dx over here. It become dx du equal to dx. For right side, you have to integrate to get v. So, you have to integrate sin x. When you integrate sin x, you'll get minus cos x. Okay, no need to put c yet. We're going to put c after we finish everything. Now, you know this one, your u dv is equals to uv minus integration of v du. Now, you just need to substitute inside the equation. Your uv is x minus cos x minus integration of v is minus, so plus here, cos x du is dx. It's not the end yet, so you still have integration here, so you need to integrate cos x here minus cos x plus sin x plus c. Alright, now let's see the second example. What if you have to integrate ln x dx? As I mentioned before, the integration by parts is usually used if you have two functions. But now we have only one function, which is ln x. Ln x, if you try to use substitution method, you cannot solve it as well. So let's try to solve using integration by parts. So first, we have to choose which one is u and which one is dv. So we have only one function here. Let's put u as ln x. So our dv is only dx. So as I mentioned before, for left side you have to differentiate and right side you have to integrate to get du and v. For du is you differentiate ln x, you will get 1 over x dx. Just bring dx to the right. Okay, then for v, we integrate dx, you will get, means this one is you have to integrate 1 dx. So 1 become x. And now what you have is u dv. So just put everything inside the equation. You have integration of ln x dx is equals to your uv is x ln x minus integration of x du is 1 over x dx. So you have to integrate only dx. Now you have x ln x minus integrate dx again, you will get x and plus c. Okay, now let's say if you have example 3, you have integration of ln x square dx. Again, it's only one function. Here, your u and dv. You cannot just take ln x here because when for dv, let's say you put dx. So remember, so your u dv is the total functions that is given to you, not only half of it. If you take only ln x, where is the other ln x? So you have to remember to take everything. So don't just take half of it. So for u, you have to put ln x and square. And again, for left side, you have to differentiate. Right side, you have to integrate to get the du and v. So differentiate ln x square, you have to use chain rule here. 2 ln x and differentiate inside the bracket, which is 1 over x. So it will be over x. And for the right side, you have to integrate dx, you will get x. Next, you have to substitute inside the formula. So your ln x square dx is equal to uv, it will be x ln x square minus v du 2 ln x over x dx. Simplify inside the integrand. So this one you will get only integration of 2 ln x. So your answer here is x ln x square minus 2 you can take out outside. So you get ln x dx. So for this one, you have to use another integration by parts, where just the same as before, example 2, where your u is now ln x only, and your dv is dx, u prime is 1 over x, v is x. So your answer x ln x square minus 2. So I just take the answer from example 2. It will be x ln x minus x, and the final answer is x ln x square minus 2x ln x plus 2x plus c. That's how you solve this function ln x square. Okay, let's see example 4. Say you have integration of x square sine x dx. So you have to choose which one is your u and dv. X square is algebra and sine x is trigo. So obviously your u is x square and dv is sine x dx. Left side you differentiate, you get du, which is 2x dx, and your v is integrate sine x dx, you'll get negative cos x. Now put everything inside the equation, you get x square sine x dx equals to uv minus x square cos x minus cos x. So here minus cos x will be plus cos x dx. Again, you have two functions here. 2x cos x dx means that this is another integration by parts, IBP. u will be 2x and dv is cos x dx. Then you have to differentiate u, you will get 2 dx, and for right side integrate cos x dx, you'll get sine x. Then put back inside the equation is negative x square cos x plus 2x sine x, so it's uv minus 2 integrate sine x dx. So, and you still need to integrate one more time here, will be negative x square cos x plus 2x sine x minus, integrate sine will get minus cos, will be plus 2 cos x plus c. Remember to put c. Another example, let's say you have, so this one is example 5. If you have to integrate x ln x dx. So for you, here is x is algebra and ln is ln function. So using liat, ln is coming first. So your u must be ln x and your dv is x dx. Okay, so you have to follow liat. Now differentiate ln x, you will get 1 over x, and integrate x dx, you will get x square over 2. put everything inside the equations, you get x ln x dx equals to x squared over 2 ln x minus x squared over 2 1 over x dx. Now when you integrate, so this one can be simplified, square over 2 over 2, now 1 over 2 in front, plus c. So you will get x squared over 2 ln x minus x squared over 4 plus c. This is your answer. Okay, now let's look at example 6. Okay, this example is you have to integrate e to x sin x dx. Okay, as I mentioned, if you have two functions and you cannot use substitution method, okay, now you have to try to solve using integration by parts. As usual, you have to determine which one's coming first. Between exponential and sin x, this is exponential, this is trigo, means that your u is sin x and your dv is e to x. On the left side, you differentiate sin x become cos x, while for the right side you integrate, will be e to x over 2. Then put back inside the equations, your integrations will be uv 1 over 2 e to x sin x minus 1 over 2 integrations of e to x cos x dx. Now you have another functions. Two functions means that you have to do another IBP here with u is cos x and dv is e to x. And u prime is cos, you get negative sin x because you differentiate here. Okay, and when your v is 1 over 2 e to x. Okay, now put back inside this equation because this IBP is just for these integrations, so you have to combine all them together. So 1 over 2 e to x sin x minus 1 over 2. So your integrations of this function is 1 over 2 e to x cos x minus 1 over 2 integration of e to x sin x x. And again, here is another IBP. So what should you do? Now, in this case, your integration here is just exactly the same as the given function. Okay, go back to the original equations or given functions. Now you have the same functions as you get here. So what should you do when you have this kind of conditions? When you have this kind of condition, you have to bring this to the left, because what you have in the left is integration of e to x sin x dx, then combine them together. So when you bring that equations to the left, so bring all of this together with 1 over 2 in front of it, because it's the whole function with 1 over 2. Sorry, here I think this negative sin x here, so the sign here is plus. Okay, so when you bring plus 1 over 2 integration of the function to the left, so it will be plus become, so this one minus plus, so the sign is negative here. Here is plus 1 over 4 integration of e to x sin x dx equals to just this, the right side will be the same function here, be 1 over 2 e to x sin x minus 1 over 4 e to x cos x. Okay, now what we're going to do with the functions on the left, since you have two equal functions, means that you can do the basic operation of to the functions, either to plus or minus. So here you have plus, means here is 1. 1 plus 1 over 4, you will get 5 over 4. Integration of e to x sine x dx. So what you need to do is just to add the coefficient in front of the integrations. And on the right side will be the same thing. Sine x minus 1 over 4 e to x cos x. Okay, what next? Our objective or our main aim is to do this integration. So we just need to make sure on the left side we just have this function. So whatever in front of it, we have to bring to the right. So we have 5 over 4, we have to bring to the right. So our integration of e to x sine x dx is, so when you bring 5 over 4 to the right, it will be 4 over 5 in front of it, and multiply with the whole function of this one. 1 over 2 e to x sine x minus 1 over 4 e to x cos x. Okay, so your final equations of this integration will be 4 over 5 times 1 over 2. You will get 2 over 5 e to x sine x minus 1 over 5 e to x cos x. Okay, so remember, in this case, the condition is when you do the integration by parts and you see the same functions here, just exactly the given function, you have to bring that to the left. Okay, thank you.